Hello, this is video 6 in the simulation and Simio refresher. And in this video, we will focus on finite buffers, blocking, reference properties, and experiment controls. And so we're going to start with the model that we have worked with previously. So let me pull that up here. There's our tandem queuing system, and you can see that we have our baseline model that we did for the first couple of videos, and then we have our dispatching model that we did for our most recent video. And the change that we're going to do now, or the addition we're going to do now, is I'm going to implement finite capacity buffers at our stations and the implications, and look at the implications of that finite capacity buffer. So to do that, what I'm going to do is I'm going to duplicate our baseline. I don't really want the dispatching model. I could use the dispatching model, but let's just duplicate the baseline model. And then we will rename this one. Let's call this one buffers. And properties, reference properties. There we go. There's our sample, our duplicated model. So we zoom out, and then let's have a look at our the basic objects. So if we look at the server objects, we know that this green line here, this is our input buffer, and this is our processing station. We also have an output buffer here. So the default server has input, processing, output. The default source has an output buffer. The default sink has an input buffer. And so what we want to do is we want to manipulate the buffer for server 1 and server 2 and look at the impact on the line throughput. Okay, so if we choose server 1 and go over here to the buffer logic, we can see that by default, the capacity of the input and the output buffer are both infinity. And so if I wanted to set this to say 0 capacity or 1 capacity or 2 capacity or whatever a fixed number is, I could just put that value in here. But that's not what I want to do. What I want to do is I want to use a reference property. And as we'll see, that will let us use the reference property as an experimental control. So to do that, let's just right click on the word capacity here. And then there's a set reference property. And I'm going to create a new reference property. I'm going to call that buff1. And you can see the little green arrow here. And that little green arrow is the symbol for a reference property. And then I'm going to go to S2 and do the same thing, except I'm going to call this one, yep, you guessed it, buff2. So I'm going to choose that. Just create a new one called buff2. And now we see a couple of things. If we go back and look at our definitions, you can see what we just did was a shortcut for creating these two values. So I could have come into definitions and created two properties and then go back to my model and set those values for the object instances, but that right-click reference property is really a shortcut for that. The other thing it does is it sets this default value based on the current value when I set it. So because both of these were at their default values of infinity, when I created the reference property using the shortcut, it set those values, their default values, to infinity also. So if I go back and look at the model properties, now we see here under the controls section of the properties, I now have my two controls, buff1 and buff2. And so if we run the model now, what we should get is the exact same behavior, because we haven't changed anything from our baseline model other than the fact that we're now using reference properties, but those reference properties are set to the default value for the instance. So again, you could go through the experiment and convince yourself that this is that we do in fact get the same thing. And so for most changes, you should actually do that. You should go back and make sure this process of verifying as you go, rather than doing too much work and then having too much to verify. So that's the way that I try to do model building. Okay, so let's set those values. And if we look at these now, if we set the values, so now I can go into my general controls and set these values. Well, let's just set them to 0. So now we have no buffers. Right? And what we're going to see is this doesn't have the effect that we want. So let me run it and you'll see what's going on here. So in fact, this buffer is always capacity 0, or it never has anything in it. And this one never has anything in it, but the corresponding output buffer. So the output buffer for S1 and the output buffer for the source just serve as the input buffers. Now, because we're using connectors here in our model, that's a 0-time transfer. And so we've really, by setting these buffers to 0, we really haven't implemented any kind of buffer capacity, because we've simply shifted things from this input buffer to this output buffer. So what we need to do is we need to set the output buffer capacities to 0. So if I do that for server 1, let's just do server 1 right now, and we'll come back to the source in just a second and run. And now we can see that this one is turning yellow. And so the yellow color signifies the symbol. The yellow symbol signifies the block state. So once again, if you go to my server and just go look at my symbol index, you can see yellow here means it's blocked. Well, that's the effect of having a zero capacity buffer here and a zero capacity buffer here. When this one's finished, then this one, when this one's finished, but this one is busy, then the entity has nowhere to go, and so the server's in a block state. So we'd like to do the same thing here for source 1, but there's nowhere for the entities to block. So when we set the output buffer here, that simply backed up the entities here when we saw that blocking state. But at the source, there is no blocking. So we need to decide what we want to happen. And so if we go to source and look at its buffer logic, we're going to set its buffer logic to 0. And now we need to also look at the balking and reneging options, because when the source is blocked, we have to say, well, what happens to those entities? Again, when we set the output buffer to S1, then we just block S1. But we need to decide, well, what happens when we block, or when the entities that are created have nowhere to go? There's no buffer, there's nowhere for them to go, and there's nowhere for them to back up. So the default behavior is there's nothing, there's no balking, the entities are destroyed. So let me back up a second. There is balking, but the entities are just destroyed. What I'm going to do is I'm going to just put a second sink in here. Right? And I'm going to send the entities there. So I can go to my source, and then I can look at my balking behavior, and I can say, hey, when an entity is blocked, I want it to go to the input at sync 2. And so that's going to mean any entities that are blocked because this one is busy and this buffer capacity is set to 0 are going to immediately go to this sink. And so now when we run our model, we can see that there's blocking here. There's never any blocking here because we don't have anything here, but we do have entities potentially that are going through the sink. So I can just fast forward if I want to see that. I could put a status label here to count, but we're not going to do that right now. Let's just go to our results, and we can look down here at sync. So here's sync 2. Of course, there's no flow time because the entity spends 0 time there, but you can see here that there are 1,500 observations. So that means 1,500 entities were balked from the source, and then are sent, because of our balking behavior, are sent to sync 2. And so again, by implementing that, we now have reference properties to specify the input buffer capacities. The output buffer capacities are set to 0 for S1. S2 doesn't matter again because we don't do anything with those entities. And for the source, we set its buffer capacity to 0, and then we set the balking behavior to go to sync 2. So we now have the basic behavior that we want in our model, and let's go have a look at the experiment. When I look at the experiment, the first thing that we see is that now for our reference properties, we have what are called experimental controls. And so in the experiment, I can set these values. So the default scenario that we have uses the default value for the reference property, and so those were set to infinity. And so if I run now, we're just going to get the exact same thing. But before I do that, I want to add one more response I want to add for our balking behavior. So the response that I'm going to get is balk percentage. And the balk percentage is going to be the number of balks, which we can get from sync 2, input buffer number entered. Oops. If I could type today. And then we're going to divide that by the default entity population number created, right? So this is going to give me the number that were balked divided by the number that were created, and so that should be the balk percentage. And so of course, if we run now, our balk percentage is going to be 0 because we don't have balking turned on because we have these buffers set to infinity. So let's let that run so I don't have to run that scenario anymore. And we should see that this is the exact same metrics that we got before. I'm going to leave that to you to verify. But now we can come in and add different scenarios. So let's add this new scenario. This one, let's just run 32 replications also, and then let's set the buffers to 0. So this is if infinity buffer is one extreme, then 0 buffer is the next extreme. And in this case, we should see some balking, as we saw 1,500 balks in our one interactive run. And so now when we run and we look at this balk percentage and we're saying, okay, over our 32 replications, right at half of the entities balk, so half of the entities that I created. So of course I'm creating entities at the rate of, what was our rate, 6 an hour? 10 an hour, 6 an hour, every 10 minutes. So go back and look at this. I don't really remember what it was. Let's see. So we're creating them at every 10 minutes. So we're creating 6 an hour, and then half of those are being rejected. So we can go in and create new scenarios, for example. So let's see what happens if I set the buffer capacities to 1. Let's just do a couple more scenarios while we're here. So let's do, I don't know, we'll do 2 and 2. And then we'll do 3 and 3. And we're not going to do all of them, so don't worry here. Well, because they're an infinite number, but we're just going to, let's just go up to 5. So we'll do 4 and 4, and then we'll do our last one, 32, 5 and 5. And so you can see the benefit here. Let me let this run and then we'll talk about that. You can see the benefit of using reference properties is because they're automatically designated as experimental controls. And so I can create multiple scenarios and evaluate against each other, as we'll see when this runs, evaluate the performance against each other in the S'more plots directly by creating scenarios and manipulating the values of those reference properties. So should be not too long here. We're up to what in all of our scenarios, 15 out of our 32, so a little bit under halfway there. Of course, I could continue this. I could do 6 and 7 and 8 and 10, and I could also experiment with different values. There's nothing saying that these have to be the same. In fact, we probably don't want them to be the same because if server 2 has a longer processing time, so we might want to have more there. I don't know, that's something for another day to do some experimentation with buffer capacities. And in chapter 9 of the textbook, if you use the textbook for your previous course, then hopefully you remember we did an experiment where we were optimizing the buffer capacity. And if you haven't done that, you can have a look at it in the online version of the textbook, again in chapter 9. So now they've all run, and so if I go look at my response results, what I'm really particularly interested in is this balk percentage. So I'm just going to go select balk percentage, and you can see here on scenario 1 we had no balking, so it's at 0, and then we could just see how that balk percentage declines as we increase the buffer capacity. So it's going to decline at this rate. And so ideally you would use this kind of analysis to decide, because if you think about either a manufacturing system, if I'm modeling a manufacturing system, then buffer capacity, there's a physical space, and so I have to pay. So it costs money to have buffer capacity. If you're doing something like a service system where you have people, then you have waiting rooms and things like that. So there is, in any realistic application, a cost for the buffers, and so you can use this type of experimentation to make a determination of what that buffer capacity should be. And then again, you can again also compare all of the scenarios. So if you have, all of the performance metrics. So again, if you look at our number in system L, obviously if we have 0 capacity buffers, then we're never going to have very many entities in the system, right? We have a maximum of 2. So when we can see that, and so it systematically increases. And then when we have infinity, that's when we get that buffer capacity that we got in our, the buffer usage, which we saw in the queuing model, where we have 13 entities in the system. So again, in summary, by using reference properties, we can easily experiment with different values of those controls. Also, as a quick note, if I go to my model and go to my definitions and look at the properties, there's also a way that I could set this to not show up as the in the experiment. So where is that here? Let's see, category name, expand, parent property name, where is that switch condition? Somewhere in here there's something that lets us say, hey, I don't want to use that. So here's visibility. So if I were to set this to false, right? If I set that to false and then go look at my experiment, you don't have that anymore. So if you have lots of reference properties that you want to use for whatever reason in your model, they don't all have to show up. Let me set this one back to true, because I want that to show up here. Where is it? That visibility is true. It's this visibility. Sorry about that. So anyway, so if you have a lot of reference properties, which can be useful in the model, but you don't want them to all show up in your experiment because they will take up a lot of screen room, then you can just set that visibility to false and then they won't show up as experimental controls.